Dan berikutnya Bapak Ibu, setelah pemaparan dari dua expert tadi, kita langsung saja akan mengundang seorang expert dari Infinera yang akan memberikan pemaparannya. Please welcome Mr. Erwin Filmer, Director Regional PLM APAC Infinera.
Good morning, everybody. Okay, this morning I will go a little bit about can the AI deliver, and you see how it links back to the two previous presenters talking about efficiency, talking about automation, etc. So this is a difficult slide to see, but for Infinera you can see that OpenWave AI is just a small portion of what we do. And as you all know, AI plays a bigger and bigger role in different parts, different industries. But for my session right now, and again linking to the previous two presenters, let's have a bit of a look at what it means for transmission networks. So the optical infrastructure that is carrying basically everything that we do. So what we're seeing when we're talking to carriers around the world is what are the drivers? What are really the drivers for AI machine learning in transport network? And interestingly, our optical communication industry suffers a little bit from gray hair syndrome. So what we're seeing is that there is an issue of aging workforce. Knowledge is slowly disappearing from the operators, from the customers. And we believe that AI and machine learning can help mine the available data and work with that. The other thing is around greener networks. We're getting more and more questions. Can you optimize the electricity, the power consumption? So using AI, using machine learning to understand where the workloads are, where the traffic are, and being able to manage the equipment power consumption. The other part is around improving network resilience. So getting early warning, getting insights on degradation of performance, and then getting recommendations on actually how to troubleshoot and improve that. But before that, let's have another look about can AI deliver? And this is the different stages, and Donnie referenced that as well, the different stages where we are. But I think the big thing is going from manual operations, very labor intensive, very repetitive, going up to assisted, partial, conditional autonomy. It is there on the far right-hand side of the chart where it's like you need to be able to trust that AI is going to do the right things. So for me and for the people that we're talking to, can AI deliver is actually more of a question, can we trust AI to do the right thing? So where we are going from is going from descriptive analytics to diagnostics to predictive and then ultimately to prescriptive analytics where the network is working on its own under machine learning. We did a market study, or actually it's with Heavy Readings assistance, and this is a chart where we had a couple of questions between where do you see yourself now and where do you see yourself as network operator in about 3 years from now. Not quite 2030, but about 3 years from now. So definitely the first bar chart is going from manual operations to automation. That is where you see a big drop in behavior in the network. What you see is that the assistant management, partial management, conditional, highly autonomous and fully autonomous. So what you see on the far right-hand side of the network is that the expectation in 3 years' time is that still only 10% of the operators expect to be in fully autonomous mode, and that most of the operators are somewhere in the middle. What are the most important applications? And this is kind of like the low-hanging fruit, and you have seen it in the previous presentations as well. So what are the predictive analytics about the network health that is on top? Network troubleshooting, again, leveraging knowledge, leveraging the large language models that we can apply on the user manuals so that you can have an artificial intelligence assistant to help you with troubleshooting. At the very, very bottom, you actually find things like software upgrade and actually the deployment and commissioning, which have kind of the lowest application score among the operators. Now, the flip side of AI and machine learning is we use the data, the streaming telemetry that comes out of the network to analyze what's happening and what we're trying to predict. What are we doing in terms of generative AI with respect to our operators? So on the top of the chart is providing reporting intelligence and network KPIs. So this is actually the ability to help your operational staff to make the monthly, the weekly reporting based on the data coming out of the network. The second one is assisting with troubleshooting. And this is something very interesting because you heard about enterprises taking AI on premises because they want to safeguard the data. Guess what? We are doing that ourselves as Infinera, where we use co-pilots internally in Infinera to do the large language model learning on our manuals, on our past trouble tickets. So we're building internal knowledge that then becomes generative AI, where you can have natural queries like, okay, this is happening in the network, and based on learning from the manuals, the assistant can then offer you solutions. And again, decreasing your dependency on the aging workforce. At the bottom of the chart comes that back, relevant information from the documentation, and somehow somebody answered they don't see need for generative AI in transport networks. Now, talking about what can we do? What can we do in optical networks when we're talking about applying AI, and when we're starting to think about full automation and going to the path of automation. So this is a case study with a major US wholesaler, and it's more than a case study. It's going into its first phase of implementation, where at the bottom of the chart, you can see the end customer of this wholesaler going into their customer portal, linking to Salesforce, Salesforce then talking to our what we call open wave manager, which is able to provision optical services across multi-vendor environment, and then actually turn up a wavelength service in less than 24 hours. Now you're saying, hey, hang on, this is still human operated, this is still a manual activity, but remember what I said, this is with Salesforce in the middle. So if you apply the AI, if you apply the machine learning capabilities that exist in the Salesforce environment, and you have a feedback loop in terms of, okay, what's happening in the network? Do I need to turn up more wavelengths? Do I order more equipment? Then you can actually imagine that on top of the Salesforce one, the AI machine learning can run in the background. So this is kind of showing how we can go from today an assisted, semi-manual environment, how we can actually have a path to full-blown, full automation. Now, AI and machine learning very, very heavily rely on data. And this is something where you need to be very clear about where does your data come from, how do you get your data. And in the Infinera case, we're working with what's called Infinera Explorer, and it takes a multitude of sources. And the key thing that you should keep in mind right now is talking about streaming telemetry. So look at your infrastructure, look at your network elements. Are they able to support you with streaming telemetry with the fine granularity that is necessary to feed the machine learning? What you'll also see is that in the use cases on the top, from inventory to capacity management to network optimization to early warning, the health, it's all interrelated. So don't think about individual silos anymore. You need to think of this as an interrelated system. Okay, I'll skip through this one. So in the last few minutes, let me just very briefly, very quickly touch on the main use cases. So on the top left, you see the virtual operational assistant. This is exactly what I mentioned earlier. Infinera, we're using our on-premises Copilot capabilities to mine our manuals, mine our previous support cases, and then being able to recommend actions based on certain behavior, certain fault conditions in the network. That is also related to the network health and analytics, again, the streaming telemetry, and that then gets you to a path for predictive maintenance. Today, we're basically firefighting as things are happening in the network, and you need to send people out in the rush in the middle of the night to fix things in the network. When you get to predictive maintenance, again, based on finding anomalies in the network, finding trends in the network, you can be much more proactive. At the bottom, it's the troubleshooting, again, using the virtual operational assistant, the network tempering detection. So these are intrusions in the optical cable, whether it's on the subsea side or on the terrestrial side, where we can use this very fine-grained streaming telemetry data to capture these intrusions almost in real time. If you think about the past, when you had your 15 minutes buckets of PM data, you didn't have that fine granularity necessary to support that. And ultimately, I think it's very, very important to ensure that your AI, your machine learning, can handle a multi-vendor environment, and this is where the necessary APIs come into the picture. So I have about 1 minute to go, and I'll just quickly recap those points over here. So generative AI, natural language assistant, again, looking at the past cases, looking at the manuals. Network health analytics, streaming telemetry. Make sure that you are ready to have your data lakes created with streaming telemetry data so that we're actually able to use it. The predictive maintenance, this is what in AI and machine learning is like finding the trends, finding the outliers, and use that data to trigger necessary actions. If you have a high level of trust, it can be fully automated. If you have a lower level of trust to your AI, then you make it assisted. The troubleshooting, again, data feeding the decision making. And the network intrusion detecting, you see there on the right-hand side. So this is using very fine-grained OTDR, state of polarization. SOP is for your coherent DWDM, so if there is interference in those parameters. And as well, again, the very fine-grained changes in optical power as intrusions happen. Now, network optimization, I didn't say too much about this yet, but you have to remember that you have probably been planning your network topologies, your network infrastructure in the past on manual work. And over time, as geographies change, as industry location change, as new cities are built, as new technology parks are being built, you would see changes in traffic patterns. Guess what? AI and machine learning can also help you to understand those changes in traffic patterns, and you might actually find that the AI could recommend to start decommissioning a particular site because it's not useful anymore. And again, this is where savings in power and space come into the picture as well. So with that, I'm just at the end of my time. Keep in mind that when you talk to your people about can AI deliver, yes, absolutely, even in optical transmission networks, AI can deliver, but it is the level of trust that you place in AI to be able to see how far you go on the journey. And with that, I would like to thank you very much, and that concludes my session.
Thank you once again. Please give a round of applause. Thank you, Mr. Erwin Filmer. Yeah, that was a very complete presentation about the technology and to answer the question, can AI deliver? Dan Bapak Ibu, itu artinya sudah 3 presentasi yang kita simak bersama untuk sesi yang pertama ini, yaitu sesi untuk teknologi conference ataupun seminar teknologi bersama dengan para expert teknologi partner.